As we're getting started here, please click subscribe, and when you get done, if you like this video, click the like button. Thank you very much. Okay, we're recording here. Today's lesson is going to be on a lot of different ways to look at it, changing the brightness of an LED and having the computer do it for you. So I've got an Arduino, and I really only need one of these hooked up, so I'll pull this one off to make things simpler. Got an LED here. It's still got the built-in LED, but I'm going to use this one because I can plug it into the digital 9 pin, and we'll talk about that in a second. The LED's got a ballast resistor I soldered in and protected so I could use it for various things during the semester. So it's really important to keep track of what you're doing and make sure that things are going to work. And at least at the beginning, this means taking very small steps at a time. So right at the beginning here, I've got my Arduino set up that none of the LEDs are blinking. And I'm going to just load up the blink demo and make sure I'm hooked up. You saw it loading up there, the light's flashing. And now you can see that light blinking on and off. And that's the blink demo sketch. So we know that that one works. And let me set this down. And then I wrote this up because I'm a terrible typist. I thought this would be easier if I typed it ahead of time and then just explained what I changed. So I took the blink demo comments from the top and I put them at the bottom because they want them in code that's derived from it, and I derived it even though it's very simple code. It also has my email address in it like I require. And I changed this. This said LED built in, but I want it to be pin 9. So I have declared a place in storage. That's what this means. I'm creating a place in storage called LED pin. And I'm taking 9 and putting it into LED pin. Anytime you see an equal sign, it's easier if you read it backwards. This says take 9 and put it into a storage location called LED pin. It's a new storage location and it is in the form of an integer. So that's minus and positive numbers. The thing that's special about pin 9 is that it's a pulse width modulated pin. That means it has a little tilde in it, one of these little squiggly lines in front of it, and we can change sort of how much this is on. And so I want to keep track of how bright the LED is, and I'm going to create a storage location and call it brightness. At the beginning, I don't want it to have any number in it. It's just sort of empty. They call it null, and I need that to be an integer also. Although I only need it to be between 0 and 255, and then a little bit more on the top and bottom. We can talk about how we might use a different kind of storage location later on in the course. I want to set up that pin, that LED pin, as an output so I can change it between 0 and 5 volts or in the levels between them. And then I'm going to go into the void loop function. This is the part of the program that runs over and over. When it gets to this squiggly brace, it goes back up to the top and starts over. And just to make sure things are still working, I've saved this one the way it is. And I'm going to load it up to my thing and we're going to see if it still works. So there you can see it loaded. And now my non-built-in, my LED that I put in there is blinking. Great. Now I got to find 3. Oh, 2. Here it is. Okay. So in this one, same thing. I've got the LED hooked up to pin 9. This time I'm setting the brightness at 255. Void setup, this is all the same. Down here, instead of it saying digital write, I'm saying analog write. What this does is it allows me to set a level, an amount that this pin is on. Really parts of a second between 0 and 255. 0 being it's always off. 1 being it's on 1/256th part of the time. 2 is 2/256ths. So as that number goes up, things are going to get brighter and brighter. And so I'm going to write LED pin and the brightness. And at the beginning, I'm just going to set it at 255 and make sure this works. So here's my Arduino again. And it's all the way on. That's really great. So that works. So next I want program version 3. This is version 3. Same pin. Here I'm setting the brightness at the beginning to 0. I'm starting the serial port. This is the way I can keep track of the brightness so that I can see what the brightness amount is going to be. And we'll see what that looks like. Pin mode is the same. Analog write, LED pin brightness. Right now the brightness is set to 0, right? So that's off. I've changed the delay to 50 because I don't want to wait too long. And you'll see why. Analog write, LED pin brightness. I don't need this. And let's change this to 100. This is redundant. It's already at that level. And then down here we have brightness equals brightness plus 1. Remember I said to read things with an equal sign backwards? Take 1, add it to what's in brightness, and then store it back in the location called brightness. So as it passes this, the first time it goes from 0 to 1 to 2 to 3. And when we run this, we'll see that the LED gets brighter and brighter and brighter. In order to be able to see this, we're going to use the serial port at the same time. And you can watch what I have here is serial print line. So this is going to print a line to the serial port. And what I want it to print is in the parentheses there, brightness. So as I load this up, there you can see it load up. Let's get the serial port up. You can see it getting brighter and brighter and brighter and brighter and brighter and brighter and brighter. The problem with this is that when it gets to 255, it's not going to get any brighter. That's as bright as it gets, and that number is going to keep increasing. Then we're going to start getting errors. And while it seems like they're predictable, they're unpredictable. So let's clear output again. Let's watch this from the start. Oh, we can't clear the output. We got to just start over. We'll load it up again. There you can see it get brighter. Or we could push the reset button on the Arduino. And you can see the numbers get bigger and the LED get brighter. So, what if we want it to start over when it gets to 255? What can we do? So here's the next version. LED pin equals 9, brightness equals 0. All of this is the same. I'm going to just get rid of these two because I don't need them. Okay, brightness equals brightness plus 1. This says if this statement is true, then do what's in these curly brackets. So if brightness is greater than 255, take 0 and put it into brightness. So reset brightness to 0. And same thing, print. This ln means print and then give it a new line. Print line, brightness. Okay. So we're going to load this one up. And we're going to watch it go. There it is, getting brighter. And brighter. And there it started again when it got to 255. We'll watch it on the serial port here. Make sure you're following those numbers. LED still all the way on. Blink! There it goes. Okay. So great. It's really kind of slow. So maybe we can speed that up. And to speed that up, we're going to set a new integer. We're going to say take 10, put it in a storage location, call it increment, make it an integer. Okay? I can't believe I left those lines in when I was proofing it, but there it is. So brightness now, instead of equals brightness plus 1, instead of taking 1 and adding it to brightness, we're going to take increment and add it to brightness, and our increment is 10, so it's going to go a lot faster. If brightness is greater than 255, make it 0. So it'll start back at 0. Great. So watch the LED. Goes faster. Right? So you can set that to be really nice and faster. Now just take a look at the serial port. You'll see that it's climbing by tens. The first time it's 0, then 10, 20, 30, 40, 50, 60, all the way up to 250, and then it resets. We never see 255. Okay. So what happens if we want it to go up and down? What can we do? Because we've used this increment and that if statement, it's really a powerful, this is sort of the most generalized decision-making way to make decisions. Brightness equals brightness plus increment. If brightness is greater than 255, then change increment to the opposite of increment. Take the opposite of increment and put it into increment. So after you get over 255, this is going to go and become minus 10. Because the first time this happens, it's going to be at 260, and 260 is not legal on one of these pulse width modulated ports. We want to immediately change the brightness to brightness plus increment. And when increment is minus 10, if you add minus 10 to something, you're subtracting 10, right? So when we get to 260, 10 is going to become minus 10. The increment's going to become minus 10. And the brightness is going to be 260 plus minus 10. So it'll go back to 250. And we can watch this happen. I got to get rid of these again if we want. I'm going to add a delay in here so we can see it. Delay, open 100, close, semicolon. And that will hopefully slow it down so that we can see it a little bit better what's happening. So it's loading up. There it goes. It's going up 250 and now it's going down. The problem is that it's going to go below 0. So we got to do something about that. We could stop it. There's a lot of things we could do. But what we want it to do is we want it to go back up. So we've got the same thing here, But what has to happen is when it gets to 0, we want the increment to be positive again. So if brightness is greater than 255 or brightness is less than 0, you change the sign on increment. You make increment equal the opposite of increment. So when it gets up to 255, the 10 becomes minus 10. When it gets down to 0, the minus 10 becomes plus 10. It should go up and down. And let's add that weight back in here so we can see what's happening. And here we go. Goes up. Down, up, and down. I keep looking at the wrong LED. Down, up. So nice and simple. And if you look, it never gets over 255 and it never gets below 0. If we want to change that, I suppose we could change the brightness to 5 here and it would get all the way up to 255 and never turn off. So that is the end of this demo for today. And hit the subscribe button before you leave. Thanks.